Okay, so let's go back to where we were. H3AS to H2AS minus. Step 1.
Okay, I'm gonna write it down with you.
Okay. Or do you want to write it up here?
I wanna have it.
Okay, that's a good idea.
Okay.
So then you tell me what to do.
Okay.
That's better. Since we kind of went over it.
Okay, so we start out with 0.1 of H3ASO4.
Okay.
And we have 0 of H2ASO4 and hydronium.
Okay.
And then you subtract X from H3ASO4.
Okay.
And you add X to both hydronium and H2.
Okay.
So then you get 0.1 minus X and X. And then your K1 is 5.8 times 10 to the negative 30. And that equals X squared over 0.1 minus X. Because, man, he always likes us to write out, what's it called? The K sub A thing, you know? Do you know what I mean? Like H2ASO4 minus plus H plus over H3ASO4.
Oh.
Before. He like marks off if we don't do that. It sucks. Okay. So then you get rid of X on the bottom.
Wait, he wants you to write like this equals this times this over this?
Yeah.
Whatever.
But he like marks off if you don't, like this, you know? Because if you don't do it, it's like, you didn't really know what you were doing. It's like, wait, yes I did. I have the right answer. Okay, so then you can get rid of X, right?
Okay, so we get rid of X.
And then we have to see if it works by getting rid of it.
So let's solve it.
So then X squared equals 5.8 times 10 to the negative 3 times 0.1. 5.8 times 10 to the negative 4. And then you take the square root of that.
Wait, what?
You multiply by
5.8 times 10 to the negative 30?
Oh my gosh. Thank you. I had 3.
So negative 30 probably. Okay.
Yeah.
And then the square root, so what does X equal?
Square root of the answer is X equals 7.62 times 10 to the negative 16.
So we look and go, okay, that's tiny, so we won't even worry about it.
Okay.
In this case, you don't even need to divide it, because you can just look and
it's
see.
tiny.
But when you start having really big numbers with other big numbers, stuff like that,
Yeah.
or weird stuff, just
You
check.
have to check. Okay.
So we got X. Okay.
So when I divide it by 0.1 to check, when I multiply it by 100 to get percent, to check.
Times, so yeah, you divide it and then times 100.
Okay. Okay, so then it's H2ASO4 minus plus H2O gives you HASO4 2 minus plus hydronium.
So
H2ASO4 minus.
H2 minus. Okay.
You missed the minus. Okay, then you start out with X, so it's 7.62.
So let's just use X. X.
Okay, and X of hydronium.
And X of hydronium. And just keep this, so we're organized. So you
Okay.
can get back to it easy.
Okay.
So we have 0 here. So we're gonna do
Plus Y, or minus Y, and plus Y plus Y.
And then if you're going backwards, just real quick while it's on my mind.
Yeah.
So if we're going backwards, K2, this is for acidic, right? So it's kind of like Ka.
Mhm.
So that's when you do like 1 times 10 to the negative 14
Over.
over this
Mhm.
would give us K2 for going
The other way.
backwards.
So, wait, but what's Ka then? Isn't K2?
So Ka is referring to like the rate for an acid.
Yeah.
Yeah, so K2 and K. I'm just saying
They're equivalent,
Ka2
right?
kind of thing. Yeah.
Okay.
I'm saying if you went the other way, make sure you know how to convert these
So like
into KB.
we're given Ka or K2,
Mhm.
and if we want to find the opposite of that.
But if
for
they give
base.
you K, like Ka
Yeah.
to Ka1 kind of thing,
Yeah.
and they say we want you to go this way from like
To
the base, so like AsO4. They want you to go from here plus water
yeah.
this way. Then you have to start going. You have to make this from Ka3
Mhm.
to Kb1.
Oh, because that's basic when it's
Yeah, so this, you're going to take Ka3,
least acidic.
which was the one for the last step
Yeah.
of the, like going from acid to base.
But it'd be the first on the basic.
But it'd be the
stuff.
first one for the basic.
Okay.
So when
then,
you do it, the 1 times 10 to the negative 14 equals Ka times Kb.
Yeah.
So then you take this, or 1 times 10 to the negative 14 divided by this, that's your Kb1.
Okay, and that Ka3 is the K3 value that we have, that
Yeah.
we've been given.
Mm-hmm.
So if we wanted to find Kb1, we would take that value, and it would be 1 times 10 to the negative 14 divided by that.
Yeah.
Okay, that makes sense.
Okay. So, okay. That's like if he also switched it, so that's good to know. But that you could do that for diprotic as well, right?
Okay.
So like K1, Ka1 and
Yeah.
Ka2, you're gonna have to know that Ka1 is actually is related to your Kb1.
Ka,
So like you have a
One.
diprotic, you have Ka1
yeah,
and Ka2.
yeah,
So this, when you do,
would be Kb1. Right?
yeah, Kb1.
Okay. And the other one would be Kb2.
Mm-hmm.
Okay, I'm gonna write that down.
Anyway, back to,
That's good to know.
so.
So like Kb2, if you had 3 steps, Kb2 and Ka2 would be the same.
Hold on. I'm sorry. Ka2 and Kb2 would be the same.
Well, like you have step 1, step 2, step 3 for acids. Step 3 would be step 1. Step 2 would be step 2. And step 1 would be step 2.
Yeah.
3. Step 3. Okay.
Yeah.
Okay. So then for this one, equilibrium would be x minus y.
Okay. What is our K?
1.1 times 10 to the negative 7.
Okay. So then we get a Y and a Y. Oh, X plus Y.
Yeah.
So here's my thing. If he's really wanting you to do this, right?
Yeah.
Now this Y is going to be more significant than the X. So this X
Is
becomes
gone.
irrelevant.
Okay.
Do you get what
Yeah.
I'm saying? Because we're going from negative 30. Well, let's look first.
Okay.
Let's just solve it.